In section 9-8, we're going to talk about systems of linear and quadratic equations. Now what we're going to do is we're going to go down to the bottom and just fill in some blanks. Today you will have quadratic equations and you will have linear equations. And you will be asked to solve the system. In these type of problems, it'd be beneficial if we had some steps. So here are your steps. Number 1, make sure they are both in y equals. Number 2, if the problem asks you to solve them by graphing, you're going to graph the line, the straight line, using y equals mx plus b, and you learned that with Mr. Lankus. And if it asks you to graph the parabola, which there will be, which is the quadratic, you're going to graph using x equals negative b over 2a, which helps you find your vertex, and you're going to have to follow that with an xy chart. Remember, negative b over 2a tells you your middle point. If the problem asks you to use substitution, you're just going to set them equal to each other. After you that, you're going to set your new equation equal to 0. After that, you're going to look to see if you can factor. After that, if you can't factor, if you don't want to factor, use the quadratic formula. Problem number 1 is solving by graphing. So we follow our steps from before. Which one of these is a straight line? Number 1 or number 2? Hopefully your answer is number 2. Let's do number 1 to begin with. Y equals x squared minus x minus 2. Now you should know that this is a parabola and that it opens up because a is positive. So the first thing we need to do is x equals negative b over 2a. Well, in this case, b is negative 1. So we do positive 1 over 2 times a, which is 2 times 1. That means that our vertex is positive 1/2. So we make our xy chart. You put positive 1/2 in the middle. You go a little lower, and you go a little higher. Okay, let's plug in 1/2. 1/2 squared minus 1/2 minus 2. Is negative 2.25, which is negative 9 over 4. The next thing we want to do is plug in 0. Plug in 0 here and you get 0 minus 0 minus 2, negative 2. Plug in negative 1, you get a positive 1 plus 1 minus 2 is 0. You guys have to be able to plot these and graph them and plug them in. So these are the points for our parabola. So I'm going to go over here and I'm going to plot them. Okay, the xy chart's going to disappear because I have to move, well, I guess maybe I don't have to move it over. Negative 1, 0 is here. 0, negative 2 is way down here. 1/2, negative 9/4 is right below there. It's real small. 1, negative 2. Look, I'm getting my mirror image. And 2, 0. Now what would probably be a good thing is if we made this chart a little bigger. The reason we're going to make this chart bigger is so that we know when the things are going to equal. So I'm going to go more to the left and more to the right. So instead of going just to negative 1, I'm going to erase the top and I want to go even lower. I'm going to try negative 2. Plug in negative 2, you get 4 plus 2 minus 2 is 4. I'm going to go up to 3. I get 9 minus 3 minus 2 is 4. Now I'm going to replot those points. Again, the reason for doing this is so I get a bigger area to work with The more points you have, the more accurate your answer is going to be. A lot of students think that if your lines don't cross whenever we do the next one, that you've done something wrong. The only thing you did wrong is you didn't plug in enough numbers. Okay, so there's our graph. Now let's talk about equation number 2, y equals negative x plus 2. You remember how to graph. Your y-intercept is b, that's 2. Your slope is what's in front of x, that's negative 1 over 1. So we're going to go up 2 and make our y-intercept. And our slope says go down 1, right 1, down 1, right 1. Keep going until you hit. Do you notice that you do in fact hit a point? I'll make that point in blue because that point is a solution. It's what they both equal. Now I know you might be thinking, well, what about the other way? I understand the graph goes down here. Can I continue it up here? Yeah, just go up and to the left, and notice it hits again. Sometimes that'll happen. Sometimes it will hit once, very rarely. Most often, it's probably going to hit twice. So I have 2 places where it hits, or where it crosses. Okay? So it crosses at negative 2, 4, and it crosses at 2, 0. Therefore, these are both solutions. If you plug in negative 2 into both of them, you'll get out a 4. If you plug in 2 to both of them, you'll get out a 0. Let's try that one more time. Okay, if you work faster than me on this one, you should get an answer of negative 2, 9 and 1, 3. I noticed that equation number 1 should be a parabola. How do you notice that? How did I know that right away? Because it has an x squared. So for parabolas, I need negative b over 2a. In this case, b is 0, so I know my x of my vertex is 0. Put 0 in the middle. Notice I'm going to include more points than I typically do. Okay, I'm going to go all the way up to 3. And I'm going to go down to negative 3. That way I get a nice graph. Let's plug our values in. Let's start at 0. 2 times 0 plus 1 is 1. Let's go to 1. 2 times 1 plus 1 is 3. Let's plug in 2. 2 times 4 is 8, plus 1 is 9. I'm squaring it as I go along. And then let's plug in 3. 2 times 9 plus 1 is 19. Okay, you can always double check on your way back up. This would be 2 plus 1 is 3. This one would be 8 plus 1 is 9. This one would be 18 plus 1 is 19. And those are reflected points. You notice that these are very large, so what I'm going to do is I'm just going to plot the middle 5 points to start with. Okay, so I'm going to do negative 2, 9. I'm going to do negative 1, 3. 0, 1. 1, 3. And 2, 9. I'll graph my parabola. And now I'm going to go to equation number 2. Y equals negative 2x plus 5. Your y-intercept is 5. Your slope is negative 2 over 1. I'm going to start by going up 5. That's my y-intercept. Then I'm going to go down to right 1, down to right 1. Oops, I went too far up for my 5. Notice when you go down to right 1, you should hit right away. And it's this point right here. That's one of our solutions. Now since we hit, let's go the opposite way. Up to left 1. Look again, you hit at a perfect point. Connect your straight line. And note your 2 answers. The 2 solutions are over 1 up 3, and left 2 up 9. In both of these equations, if you plugged in 1, you get out 3. If you plug in -2, you get out 9. Those are your two places it crossed, and therefore your two solutions. Now there are different ways of doing this. Graphing is very limited, okay? Let's write this at the top. Graphing is limited. And the reason graphing is limited, think about it. What if your answers are really big? You'd have to sit there and really count forever on your graph. Or, what if your answers aren't perfect? What if they don't meet at a perfect spot? Okay? Graphing can make that very difficult to find your answer. So let's go on to problem 2. Now it says to use elimination. I'm going to use substitution. I feel it's a little easier and it's about the exact same thing. Since opening day, attendance at a pool A has increased steadily, while attendance at pool B rose and then fell. Equations modeling the daily attendance y at each pool are shown below. What is where x is the number of days since opening? On what days or days was the attendance the same at both? And what was the attendance? Okay, so we have a constant, and then we have one that started kind of high but started falling. All right, straight line, parabola. If you wanted to graph them, you could see where the two meet. We are not going to graph them. We're going to follow the steps from the front page and use substitution. First of all, are they both y equals? Yes. Second, set them equal to each other. Now that you have them both set equal to each other, remember anytime you have an x squared, you want to set it equal to 0. So I'm going to take away 28x, and I'm also going to take away 4. Take away 28x, take away 4. Now I'm going to get 0 equals negative x squared. 39 minus 28 is 11x. 64 minus 4 is positive 60. Now I would like to divide everything by a negative. I don't like it when x squared is negative. So I'm going to divide everything by a negative 1. I'm going to get 0 equals x squared minus 11x minus 60. That helps me be able to factor it a little bit easier. Now let's think of factors of 60. Let's try to factor it. If you guys don't want to factor, fine, use your quadratic formula. I know that factors of 60, though, are 15 and 4. And to get my negative 11, if I make 15 negative and I make 4 positive, I'll get my negative 11 that I need. Now we set each one equal to 0, so x minus 15 equals 0, and x plus 4 equals 0. Solve each one. X equals 15. Solve over there. X equals negative 4. Now what we need to understand is that this would be day negative 4. That doesn't make any sense. So this is an extraneous solution. X equals 15 represents our day. So we're going to say that this is on the 15th day. And what does this mean? It means on the 15th day, they have the same attendance. But what is the attendance? Because that was part of the question. Well, all we need to do is plug it in. Well, which one would you rather plug it in? Would you rather plug it in the easy one? Or would you rather plug it in the difficult one? Well, I hope that you guys would pick the easier one, y equals 28x plus 4. It doesn't matter, either one you're going to get it right. So let's do y equals 28 times 15 plus 4. Well, 28 times 15 plus 4 is 424 people. So we're going to make a nice, pretty like answer. I'm going to say therefore, on day 15, each pool had 424 people. Could you imagine trying to graph that? Going over 15 and up to 424? I think you'd be there for a really long time.